In this video, we're going to learn about something called things called inscribed angles. We'll define what those things are and see some properties and some consequences of these properties that these things called inscribed angles have. Before we get into that, to take a minute to try to practice some algebra and solve some geometry problems involving that. Here's a picture. It looks like this is a diameter DC because it passes through this labeled point O, and that's the center of the circle. And it looks like this chord that starts at A and ends at B is perpendicular to this diameter. We know something about the lengths of these two parts of the chord, and it would be nice if we could relate them in somehow. It turns out that since this is diameter, O is the center, which means that if we were to connect A to O and B to O, we'd form two radii, and these things are the same length because every radius is the same in a circle. Also, these two, it looks like I've formed two triangles. These two triangles are congruent because they have a radius. They have a right angle because this chord and the diameter are perpendicular. So each of these are right angles. Their hypotenuse are the same length because they're the radius, and they share this leg that's the same. So these triangles are congruent by hypotenuse leg. Meaning, what does that mean? That means we can deduce that length AE is the same length as length EB. Or, according to our setup, that x squared plus 16x is equal to 4x plus 25. This is an equation with an x squared and an x in it. So in order to solve this, this is a screams solving by factoring. So I'm going to subtract. I'm going to get one side equal to 0, and I'm like the x squared term to be positive. So I'm going to subtract 4x from both sides. Subtract 25 from both sides, and 45 from both sides. I don't know why I wrote 25. And you get x squared plus 12x minus 45 is equal to 0. Leading coefficient's 1, so we need a pair of the factors of this will be a pair. The first term is x. We need these two numbers should multiply to be negative 45, but add to positive 12. Numbers that multiply negative 45 are 45 and 1, and 9 and 5, and 15 and 3. And multiply to negative 45, one's positive, one's negative. 15 minus 3 is 12. So how about positive 15 and minus 3? This tells me that x is either negative 15 or x is 3. What makes sense in this diagram? Well, these are lengths, so these numbers, when we substitute them in to our expressions, need to be positive. If you plug in negative 15 into x squared, you get positive 225. When you plug in negative 15 times 16, you get negative 240, and 225 minus 240 is a negative number. So negative 15 does not work. Plug in 3 though. 3 squared is 9. 16 times 3 is 48. 9 plus 48 is 57. So 3 does work. Similarly, 3 times 4 is 12. 12 plus 45 is 57. 3 works. So the length of is, plug that in, and you get 57. A little more straightforward that's a little bit less algebra intensive as this problem. You could solve this either by distributing the 1/2 to inside, or maybe we multiply both sides by 2. I'm going to distribute 1/2 because that's the same as dividing by 2. And looking ahead, each of these are even, so when I divide by 2, I'll get whole numbers. 3x should be equal to 2x plus 6. X is 6. There are 4 vocab terms here. I'm going to draw some pictures, and if you'd like written descriptions of each of these vocab terms, please check out the filled-in notes or the online notes 10.4 key document that's on Canvas. But an inscribed angle is an angle whose vertex is right on a circle. A central angle's vertex is in the center. An inscribed angle is central whose angle's vertex is right on the circle. So an angle such as this, whose vertex is right on the circle, is an inscribed angle. We say an intercepted arc. Intercepted means that hits or is in the middle of. We say this arc is the arc that's in between the two. It's inside of an angle. Usually we refer to the intercepted arcs for inscribed angles. So in my picture here, maybe I'll draw another one that's a little more legible. If, say, I have an inscribed angle like this, then the intercepted arc will be the arc that's in between this angle. So it'll be this arc that's made by these 2 points, this arc of the circle. When you inscribe something, you draw it on the inside of, touching, much just like an inscribed angle is a vertex is on the circle. An inscribed polygon is a polygon whose vertices are all on a circle. So, like for instance, maybe I have an inscribed quadrilateral because I have a 4-sided figure whose vertices are all right on the circle. And when you circumscribe something, that means you draw a circle around and intercept all of its vertices. So the circumscribed circle would be like the circle that touches that, and the inscribed polygon in this picture would be the polygon itself. Some properties of these inscribed angles in things. The most important one and the most basic one, the one where all these are derived from, is how we measure inscribed angles. And it turns out you can show that the measure of an inscribed angle is half of the measure of the arc. So in this picture, angle D, the measure of angle D, is just half of whatever the arc measure of arc AB is. Remember that we measure arcs by measuring the central angle that they intercept. So angle ADB is just half of angle ACB. This is another way to state this. With that in mind, there's a lot of properties we can show. For instance, if 2 inscribed angles intercept the same arc, each of them are half the measure of this arc. Well, if each of them are half of the same thing, then each of these angles are congruent to each other. So in this picture, since angle ADB intercepts arc AB, and angle ACB intercepts arc AB, they're both inscribed, they're both half of AB, they're both equal to each other. So in this case, angle D would be the same size or congruent to angle C. If you create a right triangle out of a diameter and then a point that's on the circle, so you make a right triangle that's inscribed in a circle, like ABC is, it turns out that in order to do this, if you look at angle ABC, or the angle made by this right angle, this is an inscribed angle. Its measure is half of the arc that intercepts. Well, the arc measure of is made by diameter is half of the circle. This is half of a circle. So the arc measure of every semicircle is 180 degrees, which means, so this right angle is half of 180, which is 90 degrees. Meaning an inscribed triangle, if one of the sides is diameter, then it must be a right angle. And vice versa, if you inscribe a right triangle in a circle, the hypotenuse is always a diameter. Lastly, if you inscribe a quadrilateral, so we have a four-sided figure now that's inside of a circle, it turns out that if you make a picture like this, then you're guaranteed to have a special relationship between angles that are across from each other. Namely, if I look at this inscribed angle D, D intercepts this arc that starts at this point E and goes around to G. And also, if you look at the angle that's opposite of it, angle EFG, if you go to the angle that's across from it, this angle intercepts this arc EDG. These two angles intercept arcs that completely cover the circle. Inscribed angles are half of their arc measures. If you put these two arcs together, you get the full circle, or you get 360. So if you take the measure, so these angles should add up to half of that full circle. Or if you take angle D and add it with angle F, you should get half of a full circle. Again, because inscribed angles are half of their arcs, and half of 360, which is 180. The same line of reasoning would apply to angle E and angle G. So the inscribed quadrilateral theorem says that if you have a quadrilateral that's inscribed in a circle, meaning all four vertices are on the circle, then the angles that are opposite of each other always are supplementary. They always add to 180. We're going to take these and we're going to solve a few problems to highlight them, and that'll be it for this video. Let's solve some problems involving inscribed angles and inscribed quadrilaterals. In here, let's find some angle. What's angle G? Angle G is this angle right here. Angle G is inscribed because its vertex is right on the circle, and inscribed angles are exactly half of the arcs they intercept. Angle G intercepts arc EF, which is 58 degrees, so angle G is half of 58 degrees, which is equal to 29 degrees. Let's see, arc DG, highlighted in red, arc DG is here. This arc is made by, or is intercepted by, angle E, which is 40 degrees. E is on the circle, so it's inscribed. Inscribed angles are half of their arcs. So if this angle is 40, this arc is twice as big as 40, which is 80 degrees. Let's find some angle measures in here. Find the measure of angle arc HML, H to M to L. This arc is twice as big as the inscribed angle, or the inscribed angle is half the arc. So HML is twice as big as 109, which is 218 degrees. HJL is an arc that intercepts, the same arc, that intercepts HJL, intercepts arc HML. It's also 218. These are the same size because they intercept the same arc. In this picture, angle C is 68 degrees. We want to find the measure of angle B. 68 intercepts arc AD, which means arc AD is twice as big as 68 because inscribed angles are half of the arc. That means that this angle is 136. This arc AD is 136. Angle B intercepts this 136 degree arc, and it's inscribed, so it's half of 136, which is, well, what do you know, 68 degrees. Again, angle B and angle C intercept the same arc and are both inscribed, so they're both the same size. Let's find the value of each variable in here. Wy is a diameter because point O is the center. That means that arc Wy is a semicircle, so this is a 180-degree arc. And this angle x is inscribed, so it's half of the arc intercepts, which means it's half of 180, it's 90. You could have also just used the theorem that we stated above. So this tells me that 5x is half of 180, which is 90 degrees. Divided by 5, x is 18. Lastly, this four-sided figure, this quadrilateral, is inscribed inside of this circle. We saw just a moment ago that since it's inscribed, opposite angles across from each other, are supplementary. So one relation I know is that angle B plus 65 is 180. And I also know that 3A plus 111 is 180. Subtract 65, and this tells me that B is 115. Subtract 111, and get 3A is equal to 69. So divide by 3 and find that A is equal to 23.